6.5 and 6.6, but I am going to review right quick for y'all long division, because I know y'all just walk around doing long division all the time and you never forget it. So since y'all walk around doing it all the time, I'm going to go over it. And that's because nobody remembers long division unless you just, you know, I don't know, got good retention skills, I guess. I don't know. All right. So 6.4, you do talk about long division, but you bring it up also in 6.5. So long division, you basically have one rule that you need to remember. And we will put that rule in red or magenta. And that rule is all place values must be accounted for. Okay, so before you start a long division problem, if your leading coefficient on the divisor is 2, then you have to have x squared, x to the first, x to the 0. And on the dividend, if it's x to the third, then it needs to be x to the third, x squared, x to the first, x to the 0. All those place values have to be accounted for. All right, that's the secret to long division. Why do I not show synthetic division? Because synthetic division is restricted. You can only use synthetic division when you're dividing by x to the first power. And that's why I don't show it. I don't use it. So let's do a problem like so. X squared minus 1 into x to the third plus 2x squared minus 1. Now, the leading coefficient on both the divisor and the dividend is important. Now, in order for all the place values to be accounted for, we have to go x squared, that's x to the first, and then down to x to the 0. Here, x to the third, x squared, x to the first, we need x to the first, and then this is x to the 0. You've got to remember that any constant is x to the 0. If you have a constant, that is x to the 0. Now remember, I'm not here to teach the people that invented long division. I'm here to teach the students that suck at it. So, or don't remember it very well. So that's why I'm adding the x to the 0. So I've got a place missing here, 2 and 0. I've got an x to the first missing here, and I've got an x to the first missing here. Now, how you add that, I don't care if it's a space. I don't care if it's a 0 term. I use 0 terms. So I'm going to add a term here, and I'm going to add a term here. Now, once I've added those terms, then I can do my long division. Or, in your case, a space. You may add a space. I don't know what you're going to use. X squared plus 0x to the first minus 1x to the 0. Now, I'm doing this for a reason, so y'all just bear with me a minute. And x to the third plus 2x squared plus 0x to the first minus 1x to the 0. Now, at this point, I'm going to put a big red check, a big green check mark because we have 2, 1, 0, 3, 2, 1, 0. And at this point, long division can be done. So I'm going to take my green highlighter and I'm going to put highlight there, there, and there. There, 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 and there. Now, why am I spending so much time on this part? Because of 2 reasons. One, the people that suck at long division usually either don't know this, or they didn't listen very well, or they have forgotten about it. The second reason I'm showing you is the people that think they know, they might mess it up, so make sure 2, 1, 0. 3, 2, 1, 0. Now, you're ready to start. Now, you don't have to add, you don't have to, when you start long division, you don't have to put the X to the zeros here. That's just something I'm showing you that the variables are in order and the place values are accounted for. Any questions? All right, so at that point, now we can start. So x squared, I'm going to take it over to the next page. X squared plus 0x minus 1 into x to the third plus 2x squared plus 0x minus 1. So you see at that point I dropped all the extras, but I didn't drop the place values that are accounted for because they are essential. And then you ask yourself, you want to concentrate on this guy right here. That's the guy that you want to concentrate on. You don't care about these guys because they'll fall into place. This is the kite. This is the tail. Why is this the kite? Because wherever the kite goes, the tail will what? Y'all ever flown a kite before?
Will follow.
It will follow. You're not worried about this. So many people, when they learn long division, they worry about how in the world am I going to figure out how to divide all 3 of these into all 3 of these? That's not the way it works. You worry about this guy. This guy goes into this, and these will follow. Now, just for giggles, I want to go over a 3rd grade division problem. Now, why am I doing this? Because some of y'all, when I go over long division with algebra, y'all forget the basic rules of long division. So I'm just refreshing you. 2 will go into 17. Now, 2 will not go into 1, so you skip it. 2 will go into 17 8 times. 8 times 2 is 16. What do we always do right here? We always what?
Subtract.
You always subtract. That leaves us a 1. And in this case, with algebraic division, we're going to use this as a remainder, and we're going to pull it up here and put it over the divisor. There you go. Now, those basic rules that you learned in 3rd, 4th grade, we're going to use today. I don't want you to go, well, where'd you get that from? Where'd you get that subtraction symbol from? Okay, we're following those same rules that you learned in 3rd grade. So, let's go ahead and start. X squared will go into x third, x to the first times. Got to remember your exponential laws. You add exponents. So x to the first times x to the third, x squared is x to the third. X to the first times 0x is 0x squared. X to the first times -1 is -1x. We always subtract. Now, some of you like to put the subtraction symbol out here, and some of you like to distribute it? I'm one that likes to distribute it. Since we got 3 terms here, we got to distribute it, or you've got to remember to put the subtraction symbol on each one. However you want to do it, that's fine. That's a negative, and that's a positive. Okay, however you want to do it, that's up to you. What will happen if you do things right with the first column?
It'll cancel.
It will cancel. And then you're ready for this. So now 2x squared plus 0x squared or minus 0x squared is 2x squared. 0x plus 1x is 1x or x. And then you bring down that guy to help out. You go back to your kite. How many times will x squared go into 2x squared? 2 times. 2 times x squared is 2x squared. 2 times 0 is 0. And 2 times negative 1 is negative 2. We always subtract. That makes this into a negative, makes this into a negative, makes this into a positive. First column always should cancel. And that leaves you with 1x minus 0x is x, and negative 1 plus 2 is 1, and that is your remainder, and it will go over your divisor. So your answer is x plus 2. They usually put a comma or a plus. I put a comma. And then x plus 1 over x squared minus 1. Now that is how you do long division. Now you may have a different way of doing it by putting a space here. And you may not do some of the things that I do, but I'm not here to teach the ones that know how to do it. I'm here to teach the ones that don't know how to do it or suck at it. How many of you remembered that from high school? Everybody remembered it, right? Yes, no, maybe. You're not going to talk to me?
I had it in my class last semester, so.
You had it in which class?
My class last.
What did you take? 102 or?
Yeah.
Did you take that at Tri-County?
Yeah, see, I couldn't use any of my high school stuff because it had been 10 years since I'd been. So they made me retake, like, basic.
Tell me how that 102 was.
It was pretty easy.
It was? I mean,
yeah.
I'm not talking about the math. How about the logistics of the class? Was it cumbersome or was it easy, like as far as the homework?
It was a lot of
versus
it was a fast track class, so
yeah.
I had math 101 half the semester and then 102 the second half.
So it went pretty fast.
Yeah, and we had 3 writing assignments every week we had to do for it.
That's the stuff I was talking about. I heard that y'all have to do some outlandish stuff in there.
Yeah, and we used Alex. We didn't use my math lab.
Yeah, they're the only department that doesn't use my lab math. So it's interesting. Okay, so how about somebody that hadn't had long division in a while? Does that help? Thank you. Appreciate it. All right, and y'all just disappeared. Where did y'all go? What is wrong with everything? Hold on just a second. Some reason everything disappeared on my TV screens. Some Russians. All right, so let's do a nerd. I'm going to let y'all do this one on your own, and then we'll move into the class today. So let's go with 2x squared plus 3x minus 2 into 4x to the 4th minus 3x squared plus 2x minus 1. All right, I'm going to let y'all maybe 2 minutes. I want y'all to actually do this, okay? And of course, if you can't do it, then we'll just mark that up as failure. Got 12 students, and that's about who's doing the homework. So 12 out of 21. So we've got what, 9 lone wolves? They're going to be the ones that don't know what's going on at the end of the semester. Bring their helicopter and bulldozer parents too. And it looks a little bit out of focus. Is that better? Looks better. Of course, y'all not going to tell me, but. Code of the weenies. Weaned on a pickle, not to talk during class. Miss Garcia, how's your sister? She's on the lookout.
Well, actually, we're at the beach right now, so she's totally over it. But yeah, my brother-in-law's looking out for everything. He said it's been fine. She called him this morning and checked with everything how it went last night, and things have been quiet, so that's good.
Yeah, we haven't had any more. People just come on the farm and just open doors and like on the maintenance truck and stuff like that, and then ride by and just riding slow down the road and just acting weird.
Yeah, she was saying that too, but they realized that since that road is, you guys know who driving up and down that road constantly of the different cars. So she was like, you would honestly know if a car wasn't familiar. So that's kind of a good thing. Only some people come back and forth on that road. So that's pretty good.
Yeah. Well, it used to not be any trouble when there was no houses out here. Now, I know what she's talking about. She's talking about down Chambly Road. That there's a area down there that's known for the meth and all that.
Right.
Every once in a while, you'll see one on the side of the road walking, zigzagging down the road. Yeah, that's what we have to deal with. Luckily, I don't really have much to worry about. I've got family on the left side. I've got Michelin and First Quality across the creek from me. And then I got the city sewage plant to the left of me. So I don't have to worry about people moving in beside me. So, but they travel. And they'll steal anything that's not tied down to get their meth. So. My uncle shot one last time they broke into his place. He shot one in the butt. So, with bird shot. So, we hadn't had too much trouble since then. One of those racist things they call a gun. It was just a 410. It wasn't really a shotgun. A shotgun would have done more damage. All right, so do we have anything missing? Well, let's look. This is x to the first. I'm going to do this in a different color so you can say, okay, this is what we need to do first. That's to the first. That's to the 0. So that's good because this is a 2. 2, 1, 0. This is a 4. So we got to go all the way down to 0. So let's do that. 4, 2, 1, 0. So we're missing something. So we got to either add a space or add a term. So here we go. 2x to the second plus 3x minus 2. 4x to the fourth plus 0x cubed minus 3x squared plus 2x minus 1. Now you're ready to start. All we had to do was add one term. Where's our kite? Our kite is right there. So you worry about this guy. How many times will this guy go into this guy? Now, don't say 2 times because 2 times is not right. How many times will 2x squared go into 4x to the 4th? That means I want somebody to say something. It's called a Q.
2x squared.
2 what?
2x squared.
2x squared. Thank you. Now you do your multiplication. 2x squared times 2x squared is 4x to the 4th. 2x squared times 3x is 6x to the 3rd. 2x squared times negative 2 is negative 4x squared. And we always what? Subtract. And that makes this guy a negative, makes this guy a negative, makes this guy a positive. And of course, the first column should always cancel. And 0 minus 6x cubed is negative 6x cubed. Negative 3x squared plus 4x squared is 1x squared. And I'm only adding these coefficients and variables to the people that need it. I'm not, you don't have to write them if you know what you're doing. And plus 2x comes down. Go back to the kite. 2x squared will go into negative 6x cubed. How many times? It's going to be negative.
Negative 3x.
3x times. Good job. Now do the multiplication. Negative 3x times 2x squared is negative 6x cubed. Negative 3x times positive 3x is negative 9x squared. Negative 3x times negative 2 is negative positive 6x. You always subtract. That makes this a positive, makes this a positive, and makes this a negative. So this goes out. And 1x plus 9x squared is 10x squared. 2x minus 6x is negative 3x. And the 1 comes down to help out.
Negative 4x.
I'm sorry, what? Oh,
Negative 4x.
How did I get 2? And, oh, I was thinking of 2 times 3, I guess. Sorry. 2 minus, thank you. All right, go back to the kite. 2x squared will go into 10x squared 5 times. 5 times 2x squared is 10x squared. 5 times 3x is 15x. And 5 times negative 2 is negative 10. You always subtract. That makes this a negative, makes this a negative, makes this a positive. And this goes out the way it's supposed to. Negative 4x minus 15x is negative 19x. And negative 1 plus 10 is positive 9. And that's your remainder. So your answer is 2x squared plus 3x minus 2 will go into all this trash. 2x squared minus 3x plus 5 with a remainder of negative 19x plus 9 over 2x squared plus 3x minus 2. Now you could write the remainder and just put an R here and put negative 19 plus 9. It all depends on what the directions say with your question. I'm leaving that on the board there for a few seconds, so the one person that does use the videos can pause it if they need to. Now, is that a good refresher? I hope that's a good refresher. Now, let's pull up the handy dandy thing I sent you right before class, because we're going to be talking about vertical and horizontal asymptotes. And this is you ever have a word that you always have to look at it to spell it? Well, that's my word, asymptotes. I have to actually look at it because it's hard for me to spell it. Okay, I'm not perfect like some of y'all. All right, there it is, asymptotes. It's T-O-T-E-S. A lot of people think there's a P there, like in Clemson. I'm sorry, Clemson. Okay, so there's not a P there. It's not asymptotes. It's asymptotes. And you have to put a symptom right there. So asymptom. So vertical and horizontal asymptotes. A-S-Y-M-P tote. Y'all ever have a word that y'all have to have help with? Necessary. I cannot stand that word. I will write a total paragraph I cannot stand that word. Anybody have a word they can't stand? And nobody's going to talk. So. Miss Taylor, do you have a word that you can't stand to spell? She done left.
Like convenience.
Convenient. That's another good word.
Or maintenance.
Maintenance. You know how I do maintenance? Main 10 ants. I have to do it by syllables. Kind of like business, busyness. I have to do that. I've been doing that since like 5th grade. But asymptotes, that word sucks. Anyway, and some of y'all hate the word moist just because y'all hate to hear the word moist being pronounced moist. I have found that is the biggest word in my classes that students hate. They hate that word. I don't know why. Moist. I don't care. But some of y'all can't stand that word. I know there's somebody in here that can't stand that word. So if you want to speak up, go ahead. But there's people that hate that word. Not because they spell it. They can't stand the way it sounds. Moist. Moist, moist, moist. Okay. Vertical and horizontal asymptotes basically is convergence. Convergence. Can anybody tell me, hopefully I spelled that right, I don't know if it's E-N-C or A-N-C, but convergence. Is convergence, what is convergence? Somebody give me a layman's definition for dummies. What is convergence? When you converge onto the interstate, what is that? Okay, I know that y'all are the weenie patrol, and I know that y'all are weaned on a pickle, but I'm asking y'all a question, so I want y'all to answer it. So somebody, when you converge onto the interstate, what are you doing?
Yielding.
You're yielding. What else are you doing?
Joining.
Joining. Another word is approaching. Aren't you approaching the traffic? You're approaching the traffic. When you go down the ramp, you're approaching the traffic, what? Slowly. You're approaching slowly. Now, you stop converging when you are actually in the traffic, okay? Basically, converging means that you're approaching slowly. And you never get there. Okay? You never get there. You never touch what you are approaching. Think of it like this. Let's say I've got a wall right here. And this is the floor. And I tell Mr. Kaczynski Beckett, I tell him that I want him to take a side step. This is Mr. Beckett. I tell him I want him to take a side step toward that wall. And every step after that side step, I want him to take half of the previous step. So let's say his first step is 4 feet. What will his next step be? That means I want somebody to communicate. Half the previous step.
2 feet.
What?
2 feet.
2 feet. And what will the next step be?
1.
1, and then 1/2, and then 1/4, and then 1/8, and then 1/16, and then 1/32, and then 1/64, and then 1/28, and so on. Will Mr. Beckett ever reach the wall?
No.
No. So let's write that down in red. And you have your definition of limits / convergence. Mr. Beckett will never reach the wall. Now, you have to think out of the box here. Can Mr. Beckett take 1/64th of a foot of a step? No. At one point, Mr. Beckett is going to get to where he can't move because he can't take 1/256th of a step. But mathematically, will he ever reach the wall? No. He will get within a width of a hair, but he will never, ever, ever, ever get to the wall. Does everybody understand that? That is what we call a limit. And the vertical and horizontal asymptotes, this is your calc. I just got through teaching my 140 limits, okay? And we use this as a launching pad. You got to remember a limit is the same thing as an asymptote. It's converging, it's getting next to a number, but it never what? It never touches that number, or it never includes that number. Okay? It never includes that number. All right. So, a vertical asymptote looks like this. I'm going to use 1/x² as an example. 1/x². There's your function. Now, your family of graphs tell you that 1/x² looks like the volcano. There it is. The vertical and horizontal asymptotes here. The vertical asymptote is x is equal to 0. There's your vertical asymptote. Your horizontal asymptote and from here on out, I'm not going to write asymptote every single time. Those are your two: vertical asymptote, horizontal asymptote. Your horizontal asymptote is y is equal to 0, which is the x-axis. Now, a lot of your parent graphs are going to have the x and y axis as the vertical and horizontal asymptotes. Okay, so the vertical asymptote, x is equal to 0, which is the y-axis. And horizontal asymptote on x squared is y is equal to 0, which is the x-axis. Now, what does that mean? Well, the vertical asymptote says you can't use this number in the function. And that's called excluding, which is the opposite of including, which I was talking about a while ago. So what happens if I plug 0 into the function? It blows up. And that's what the vertical asymptote represents. It represents the number that blows up the function. And a lot of you say, well, Hubert, that's a word you made up, blows up. No, it ain't. I had 3 professors at Clemson that used that word all the time, talking about convergence, talking about vertical asymptotes and the theory behind the function blowing up. In other words, that's not sophisticated. It's an undefined function and it does not have a solution at that point. Okay, that's what it means. It blows up. Now, what is the horizontal asymptote? The horizontal asymptote is just like the range. What does the range always feed on? The domain, right? So the horizontal asymptote always is going to feed off the what? The vertical asymptote. If I can't plug in 0 here, then my range is going to be affected because I cannot use that number, and that's going to affect my range, which is from 0 to infinity. So the vertical asymptote is the boundary for the range. So my range cannot be below 0 because of I cannot use 0. Okay. Now, that's the vertical and horizontal asymptote. There's also one more. It's called an oblique asymptote. And I'm not even going to try to spell that. Oblique asymptote. Okay? An oblique asymptote is a product from your long division. And we'll get into that in just a second. All right, so here is what we're going to study in this section of 6.5. Yeah, 6.5. Because we're going to be dealing with rational functions. And remember what I told y'all way back in the review. And I'm going to write this in red. Domain is affected. And I'm sorry, I've never understood the affected and the effected. I've always thought that effected means that it's actually doing it, and affected means it's after the stand, after something has happened. So if I use the affected word wrong, I'm sorry, get over it. Domain is affected. Well, I forgot what I was talking about. Domain is affected when you are dealing with a rational function, meaning a fraction, a radical, or a log. Why? Because you can't take the natural log of a negative number. You can't take the square root or the fourth root of a negative number. you can't put 0 in the denominator. So the domain is affected with these three things, and since we are dealing with a rational, it's going to have a vertical and horizontal asymptote. Capiche? So we're dealing with these right now. Rational is 6.5, I think. Now, how do you find the vertical and horizontal asymptotes? Well, that's what I sent you. I sent you the horizontal asymptotes right here, okay, because the vertical is easy. What do you mean the vertical is easy? You might want to write it down on this thing. The vertical, and I can't seem to get my cursor to work on this, but anyway, the vertical asymptote, you set the denominator equal to 0. Set the denominator equal to 0. That's how you find the vertical asymptote. So if I give you the following problem, f of x is equal to 1 over x minus 3, you're going to set the denominator equal to 0 and solve. And that will give you your vertical asymptotes. Maybe more than one. If you're dealing with a quadratic in the denominator, it will be more than one. Why are people dropping off the videos? I only got like 8 people on video. What's up with that? People leaving the class or what? I'm looking, there's 13 people in here. Where's the videos?
I'm just making breakfast really fast.
Oh, okay. Who was that? I don't know who that was.
That person.
Okay, well, just making sure. Mr. Scanley, y'all can't see him. He's a demon. All right, so well, x minus 3 is equal to 0. X cannot equal 3. So your vertical asymptote for this function is at x equal to 3. 1, 2, 3. And a vertical asymptote is a what? A vertical dashed line. Now we know that 1 over x is half a volcano because your parent graph. We know that 1 over x is a half a volcano like this. So your function will look something like this. Now, on these problems, you're going to be using your calculator to help you with the graph. I'm not going to make you try to do every single graph by hand. I want you to be able to use your family of graphs and your horizontal and vertical shift. I want you to be able to do that and check it with your graphing calculator. All right, so we just found the vertical asymptote for this function. And that's how you do it. So let's do an order. F of x is equal to 2 over x squared minus 2x. And let's see, I got to have a, let's go with a 5 and a 7. Let's go with 35, minus 35. And we know this function is a 1 over x squared, so it's going to have some kind of volcano look to it because it's something over x squared. We can rewrite this as 2 times 1 over x squared minus 2x minus 35. Can somebody tell me what that 2 tells us since it's out front? What can that 2 tell us? This is from our orientation, vertical, horizontal shift section. What can that 2 tell us? Where'd Miss Garcia go? Miss Garcia, you still with us? She disappeared. Everybody's leaving us. Somebody tell me what that A means. What does that A mean? What does 2 mean? Is it going to be compressed or is it going to be squatted? Come on, somebody tell me.
Press.
Compressed. It's going to be skinny. So this right here, you're going to be, since that 2 is right there, it's going to be compressed like that, which will make it look a little bit more like, instead of being wide down here, it's going to be a little bit closer to the origin like that, because it's being compressed. It's being like that. All right. And we're going to factor this. So f of x is equal to 2 over x, 5, 7. This means that the biggest number has to be negative. And this means unlike signs. So set the denominator equal to 0. X cannot equal -5 and +7. So we know we have vertical asymptotes at -5 and +7. And no, you would not know how to draw this unless you plotted points. So you would go to the handy dandy calculator and you would put y is equal to 2. I'm going to put 2 in parentheses divided by parentheses x squared minus 2x minus 35, close parenthesis, and graph. And you can't see jack, so you hit zoom standard. And you see your 2. Oh, I know, there's your volcano. The volcano is, and you can't see it because of the, but you vertical, I'm going to draw this so you can understand. The calculator does not put the vertical asymptotes in there. So your graph, if you was to draw it on a piece of paper, 1, 2, 3, 4, 5, -5, and at 7, I believe, 1, 2, 3, 4, 5, 6, 7. And you've got a graph that looks like that and pretty much like that. Sorry. And I'm going to show it to y'all in just a second. And pretty much like that. So it looks something like that. And this is -5 and +7. And that's how you find the vertical asymptote. Set denominator or the radicand equal to 0. So what about the horizontal asymptotes? Well, that's where you need this little guy right here. And since I couldn't make it get any bigger, let's see, where is view, zoom? Let's go to 125%. Because I know somebody's going to complain. So, oh, man, this mouse is driving me crazy. There you go. And I don't know why it's turning all kinds of colors there. All right. What if the degree of the numerator is less than the degree of the denominator? Well, let's see if they give you one like that right here. Number 3, f of x is equal to x squared plus 4x over x cubed minus 8. Okay, there you go. So the degree of the numerator is less than the degree of the denominator. So let's look at the degrees. Here's the degrees right here. You got a degree of 2 in the numerator and a degree of 3. So the numerator, the degree of the numerator is less than the degree of the denominator. Therefore, your horizontal asymptote is equal to 0. So write that down however you want to write it down, or you can keep this, you know, for the test or whatever. Capiche? But what about the vertical asymptotes on this one? Well, you got to use shortcut number what? Shortcut number 5. What the hell are you talking about, Hubert? Well, I'm sorry. I showed them to you in the review. So that'd be x minus 2 times x squared plus 2x plus 4. And that is shortcut number 2. And you can set these equal to 0. Although this one probably will not work very well. Let's see, 2 and 2, 1 and 4. Yeah, this one will not work. So they probably won't ask you to do the vertical asymptotes on this one. But that's how you would do it. If you had one and they said, blah, 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 what are the vertical and horizontal asymptotes? You would check the degrees, and then you would set the denominator equal to 0. And this one is not factorable. So you would actually, if you set that one, ooh, we could use complete and square. So let's use complete and square. I know, I'm a geek. Equal to 0, and x squared plus 2x plus 4 is equal to 0. And x cannot equal 2. So if you use 2 in this formula, what will you get? Well, 2 cubed is 8. 8 minus 8 is 0. You get 0, Hubert. That's right. So you can't have that. Now let's do this. X squared plus 2x plus blank is equal to negative 4 plus blank. What you're going to get is a negative, which means no solution. And I said that when I said this wasn't factorable. But we're going to test it with complete and square because you never need to forget how to do complete and square unless you want to fail calculus. So half of 2 is 1, 1 there, 1 there. X plus 1 quantity squared is equal to negative 3. And at that point, you know that there's no solution because you can't take the square root of a what?
Negative.
Thank you. No solution because you can't take the square root of a negative. So you're going to get terms of I, which means imaginary numbers, which means that the horizontal asymptote in this case is going to be 0, and the vertical asymptote is going to be negative, is going to be equal to 2. So in this case, in this scenario, you got a horizontal asymptote of y is equal to 0, which is the x-axis. And you've got a vertical asymptote of 2, which means you got a vertical asymptote like that. So whatever your function looks like, it's not going to touch these two lines. So let's see what it looks like. Let's take our handy dandy calculator. And let's do y is equal, clear it, and parentheses, x squared plus 4x, x squared plus x squared plus 4x, close parentheses, divided by, parentheses, x cubed minus 8. X cubed minus 8. Close parentheses and graph. And there is your horizontal and your vertical asymptote. So it basically looks like this. Hold on. Where is my, there. That's what it looks like. And I'm going to tell you something. I've sat through a lot of algebra classes where I evaluated teachers, and teachers can lobotomize students on vertical and horizontal asymptotes. Okay, so if you have a question, you better speak up. All right. So this one was a case of the degree of the numerator is less than the degree of the denominator. So your horizontal is always going to be 0. Then set the denominator equal to 0 to find your vertical asymptote. Okay. Well, what if they're equal? Well, let's look at the example and see which one is equal. Pull up our example here. Looks like the first one is equal. And what is, if the degree of the numerator is equal to the degree of the denominator, horizontal asymptote is the leading coefficients. So here we go. G of x is equal to 6x cubed minus 10x over 2x cubed plus 5x squared. And the degree of the numerator is equal to the degree of the denominator. So let's write that down. Degree of the numerator is equal to the degree of the denominator. Therefore, the horizontal asymptote is equal to the leading coefficients. Leading coefficients. What is the leading coefficient? Well, it's the leading term. What is the leading term? What has the degree in it? So this is the leading term, and this is the leading term. What's the coefficients of the leading terms? We'll do that in blue.
6 and 2.
6 and what? 2. So I go over here and I put horizontal asymptote is equal to 6 over 2, which is equal to what? So your horizontal asymptote is 3. So let's find our vertical asymptote. I'm killing 2 birds with 1 stone here, because if I give you a 6.5 question on a test, I want you to find the horizontal asymptote, the vertical asymptote, and I want you to graph it or sketch it or do it on the calculator. That's the 3 things I want you to do out of 6.5. So 2x cubed plus 5x squared is equal to 0. And factor out of x squared. 2x plus what? 5? Y'all check my algebra. X squared is equal to 0. X is equal to 0. So we got 1 vertical asymptote and that is the y-axis. And then 2x plus 5 is equal to 0. 2x is equal to negative 5. X is equal to negative 5 halves. And that's the other vertical asymptote. So we've got a graph that has a horizontal asymptote, which is the 3, sorry. 1, 2, I'm sorry. 1, 2, 3. And that is your horizontal asymptote. And then we've got a vertical asymptote at what? 0, which is the y-axis, and negative 5 halves. 1, 2, 3, negative 2.5. So I'm probably going to get some kind of graph that looks like this, then a U in an opposite direction, then like this. Something like that. Or it could be, since it's a cubic function, it's going to be, yeah, it could be like that. So let's look at it. Take your handy dandy calculator. Y is equal to, clear, parentheses, 6x cubed minus 10x, 6x cubed minus 10x divided by, parentheses, 2x cubed plus 5x squared. Doing this with a mouse is so tedious. Ah! Sucks. Delete. There. And I make sure I typed it in right. I hope I did. And you see, there it is. Okay. So we've got there's the cubic function in the middle. So we've got the half a volcano here. Then we got the cubic function, which is like this. And then we've got like that. So there is what it looks like. Well, what do you do if the degree of the numerator is greater than the degree of the denominator? Well, that's where you use your long division. I'm glad he went over long division before class. All right. So if the degree, let's go back to our example. And there it is, x squared f of x is equal to x squared minus 4x plus 1 over x plus 2. And I'm putting a little 1 there so you know that the degree of the numerator is greater than the degree of the denominator. You're going to use long division, and you may get an oblique asymptote. Okay, you may get an oblique asymptote, but I'll show you in just a second. So I'm going to take x to the first plus 2x to the 0. So everything's there. And let's check the other one. X squared minus 4x to the first plus 1x to the 0. So everything's there. We don't have to worry about missing terms. So I'm going to rewrite it, or it doesn't matter. X, here's the kite. So how many times will x go into x squared? X times. X times x is x squared. X times 2x to the 0 is, well, that's 1, so that'd be 2x. Always subtract. That's going to be a negative. That's going to be a negative. This always goes out. Negative 4x minus 2x is negative 6x. The 1 comes down to help out. How many times will x go into negative 6x? Negative 6 times. Negative 6 times x is negative 6x. Negative 6 times 2 is negative 12. That goes out. You're left with a 13 remainder. And we, as a oblique asymptote, we really don't care about this. So I'm just going to kind of put a light x. We don't really care about that. All we care about is this. This right here is an oblique asymptote. And you'll see what that means here in just a second. I've got to hurry because some of y'all are going to start convulsing. All right, let's do our vertical asymptote. So that's going to be x plus 2 is equal to 0. X cannot equal negative 2. So we've got a vertical asymptote at negative 2, and we've got a oblique asymptote at x minus 6. So let's draw the sketch. We've got a vertical asymptote at negative 2. And we've got an oblique asymptote at x minus 6. 1, 2, 3, 4, 5, 6. And it's a positive slope. So that means it's going this way. And it's 1 to 1, which is a 45-degree angle. And there is your vertical and horizontal. I meant your vertical at x is equal to negative 2, and your x, y is equal to x minus 6 as far as an oblique. So what does your graph look like? Well, chances are it's going to look like this. And then down here, like that. So let's see what it looks like. So we're going to go to the graph, and we're going to go y is equal, clear, and we're going to do parentheses, x squared minus 4x plus 1, close parentheses, divided by parentheses, x plus 2. And graph. And of course you can't see the, okay, don't have the bottom one or I can't see it, but I'm just going to throw in the horizontal, I meant the oblique asymptote, and I'm going to color it, I'm going to do a dashed, I'll leave it magenta, right there. And we're going to type in x minus 6. And you see it there. See it going through there. And y is equal to negative 2. I think if you go out a little bit, you might get another part of it down here. But I don't know. Let's see. Zoom back. Yeah, let me go down here a little bit, right there. There it is. And that's it. That's 6.5. Vertical and horizontal asymptotes. So if you followed those 3 questions that I've got, and you got 3 examples right there. Right there, you got your 3 examples. So if you were smart on your sheet, you should have written right here, 0. Horizontal asymptote equals 0. Here, horizontal asymptote equals 6/2, which is equal to 3. And horizontal asymptote by long division equals oblique asymptote, OA, which is negative or x minus 6. So you should have wrote those 3 right there, because that way, when you get to a problem on the test, you can compare it to the degrees here, and it'll help you out. Anybody got a question? I mean, I know I've got the 12 people here that are doing the homework. Okay, let's go over one more thing right quick. And a lot of you going, well, why in the hell is he telling that us again? Well, I'll tell you why. Okay, and after I tell you. So if I give you a test back and I have accidentally gave everybody 30 points extra, are you going to raise your hand and say, Hubert, you gave us 30 points extra, you need to take it off? Are you going to do that? So if you go to the homework and the test and you see something that's to your advantage, are you going to email me or send me a message that says something ain't right? Or are you going to take advantage of it?
Take advantage of it.
You're going to take advantage of it. Now, why am I telling you all this for the 2nd or 3rd time? Because the lone wolves, the 9 or so students that are not coming to class, they're not going to know what I'm talking about. And I'm going to say, well, they're going to say, oh, well, I wasn't able to do this and I wasn't able to do that. I gave you 2 weeks. And they go, oh, I didn't know. And then they use that I didn't know to try to hold tie me into giving him extra time. So I'm covering my bases here, and I'm making sure that at least every other day I'm announcing that there's something in the homework and the test that you need to check out because it's to your advantage. Okay? So that way you don't have the excuse at the end of the semester, oh, I didn't know that. Well, sorry, you do now. I'm not talking to the 12 that are actually working. I'm talking to the 9 that are going to be lost in space after the grade turn in. All right. Anybody got questions? Okay. Tomorrow we will try to finish up. Do not go ahead of me because I haven't decided what I'm going to do about chapter 7. I don't know what I'm going to do there. And I don't know how much I'm going to do in 6.6. So I would not go ahead of me if I was you. I would be working on 6.1 through 6.3 and then work on 6.5. That's what everybody should be working on. So if you want to do extra work that's not going to count, go on ahead of me and don't cry when I say we're not doing that. All right, any questions? Let me check the roll. Let me check it right quick because I only got like 2 names to check. And then